So today we're going to talk about doing higher powered roots. So for example, cubed roots, quartic roots, fifth roots, etc. We're also going to talk about how to write roots in terms of exponents. So one of the first things we want to talk about is if you have a number to the nth power that equals a, that's the same thing as saying that, well, b is the nth root of a. So if you want to get rid of a number that's in an exponent, you have to take that kind of root of both sides. So if this was a squared, you'd have to square root both sides. If this was a cubed, you'd have to cube root both sides. We're going to have to go from radical form to exponential form over and over and over, and the same way the other way around. So we're going to go from one form to another very often. So I always tell my students, whatever number is under the radical, or whatever the exponent is, that is the numerator. And whatever type of root you have is called the denominator. So this would be the power of your radicand, and this would be the type of root that you have. Now there is a special name for types of roots. It's called the index. So if you have a cubed root, the index is 3. A square root, the index is 2. A quartic root, the index is 4. So whatever little number is out here, that's called the index. So this is a square root. 6 is the same thing as 6 to the first. So this is the same as 6 to the 1/2 power. That is the square root of 6. Letter B, I want to keep the 2 as my numerator. The index is my denominator, so it's x to the 2/3. This would be y to the 1/3 and y to the 1/4. So it's very simple to go from radical to exponential form. It's a matter of just putting your numbers either on top or bottom. Now it's a little trickier to go from exponential to radical form because you do have to simplify your radicals. So for example, if you had like root 12, that's not done. You have to change that to 2 root 3. So this is the same thing as saying the cubed root of 8 squared. Another way to think of it is 8 is the same thing as 2 cubed. So 8 to the 2/3 is the exact same as saying 2 cubed to the 2/3. If you think of the cubed root of 64, if you have it memorized, you'll know that's 4. The cubed root of 64 is 4. So that's if you do it from a radical standpoint. If you use exponential standpoint, you would distribute 2/3 times 3, and you would get 2 squared, which is still 4. So either way you look at it, you get 4. But sometimes we need to use this exponential representation, especially when we are not allowed to use a calculator or we have bigger numbers. 6 to the 1/2, so we're just going backwards. We want to make it the square root of 6 to the first. 12 to the 1/2 is the same thing as the square root of 12. Another representation is to change 12 into 2 squared times 3. You can distribute the 1/2 and make it 2 to the first times 3 to the 1/2, which still gets you 2 root 3. Right? 10 to the 1/4 is just the quartic root of 10 to the first. 64 to the 1/3 is cubed root of 64, which we know is 4. Another way to think of 64 is 4 to the third. So if you have 4 to the third to the 1/3, you will still get 4. Now J is going to be a little trickier because we would have to do the square root of 20 cubed. Now that's getting a little bigger. It's doable, but it might be easier to write 20 as 2 squared times 5, distribute the exponent, and get 2 cubed, 5 to the 3/2. We're going to learn this a little later. It's not good to have an improper fraction as an exponent, so we want to change 3/2 into 2/2 and 1/2. If you add those exponents, it still makes 3/2, but the reason we want to break it up like this is this becomes 5 to the first, and you can multiply that with 8 and get 40, and you'll just be left with root 5. So we definitely do a lot of practice with situations like this, and it'll come easier to you over time. Just we want you to keep an open mind that these exponent rules can come in very handy if we don't have access to a calculator. So we are going to practice evaluating each of these expressions without a calculator, and what you should notice is all of these numbers are special. 4 is a square, 32 is actually 2 to the 5th power, 625 is definitely a perfect square. and so is 49, and 125 is a cube. So you want to be on the lookout for special numbers, and you want to change them. If they're small enough, you can change it to radical form. Like we can probably do the square root of 4 cubed. If you can do 4 cubed, you know it's the square root of 64, that's 8. If I was doing letter I probably don't want to do, I could write the fifth root of 32 to the fourth, but not many people can do 32 to the fourth. If you change 32 to 2 to the fifth, and then distribute the 4/5 in, you'll get 2 to the fourth, and that's just 16. So that answer becomes 16. 625 is special because it's 25 squared. But even 25 itself is special, so I could change 25 into 5 squared and then keep this outside squared. So 5 squared squared is the same thing as 25 squared. So in essence, 625 is actually 5 to the fourth power. So I'm going to change this into 5 to the fourth to the 3/4 power. I'm going to distribute my exponent and get 5 cubed, which is now 125. If I was doing k, I would definitely change 49 into 7 squared, all to the 3/2. I would distribute my exponent and get 7 cubed, which is 343. And if I change 125 into 5 to the third, raise that to the 4/3, and then distribute my exponent, I'll get 5 to the fourth, which is 625. So we really want to be on the lookout for these special numbers and try to change everything to exponent form because it will probably simplify our workload. So in my next video, I'll go ahead and take you through examples 1 through 5 and talk about how to figure out what they're asking you to do.